Welcome to this third installment on using R for social work research. We hope the first two presentations were helpful in convincing you that R may have a place in your research toolkit, data analysis toolkit. We think, as you could tell by the previous presentations, it has great strengths and flexibilities and attributes that are attractive to people who are analyzing data in our field. So hopefully we can continue to try to underscore the usefulness of R in the work that you do. So in this third presentation, we have a couple of goals that we want to meet. We're trying to keep these presentations fairly short so that you don't have to sit through long expositions listening to my voice especially. So we're trying to do these things in a kind of crisp manner. So today what we want to do is take a look at how we can move an SPSS file or import an SPSS file into R. Many social work researchers, including me, use SPSS as a data analytic tool and have for years done that. And it's very popular and has evolved nicely in some ways when IBM took it over. It really has. It's really expanded its capacities, I think, in important ways. Some of you maybe use Stata or Stata. I never know how to pronounce that, Stata or Stata. And that's an equivalently effective package for sure. You might use SAS and maybe Systat. So that notwithstanding, we want to see how we can pull in an SPSS file into R and do an analysis using that SPSS file, knowing that you could do this with other packages as well. So we want to do that as a goal. It's fairly simple and straightforward. We also want to take a look today at how you'll end up likely using multiple libraries in any analysis that you do, even a simple analysis. Libraries tend to be a little bit specialized in R, so that if you have some tasks that you want to do, you might have to find a range of libraries. And I know that sounds a little onerous. It's really not as bad as it sounds, but you'll end up using multiple libraries nonetheless, and it's pretty straightforward. So we want to take a look at that, and we want to maybe have a quick look at some important factors regarding programming. R is a command line environment, basically, and what that means is that you have a command line and you submit instructions at the command prompt, and then R executes it and keeps it in memory and all that. So it's I don't know if you're used to or familiar with command line stuff, but that's how R operates. The nice thing about RStudio is that you can create scripts that that you would literally submit at a command line, but they're in a sort of programming compilation, which makes it a lot easier than trying to do command line stuff in R, which is, I think I said in the first presentation, a pain. So RStudio lets us do things very nicely. So we want to take a quick look at that, and then maybe look at just a comment or two about programming structure. That there is, if you're not used to actually developing scripts, there are some conventions that are helpful, mostly to eliminate the possibility that you'll end up with what we call spaghetti code. So we want to try to do that as well. So actually, now that I've gone on and on, it sounds a little bit more ambitious maybe than it'll turn out to be, but they're important topics that I think will be helpful for you as you move along in your R journey. So on the screen, I have the SPSS data file that we're going to be taking a look at. This is a data file of 13 items from a micro threat scale that Natasha Bowen and Gary Bowen at the University of North Carolina developed. Basically, I'm not sure of the developmental history, but I do know it's was formerly a part of this particular version of the school success profile, and it's really a very nice scale. And if you're interested in the measures, we could go over and take a quick look here in the annotation. So these are the questions that get posed, and they are measures of micro threats. Basically, you can see the questions here, and the response scales are never, once or twice, and more than twice. So they're ordinal in their level of measurement. I know it shows up as scale here, but they're ordinal in their scale of measurement. So what we want to do to illustrate the points that I elaborated a little bit earlier is to pull this file into R and do a fairly straightforward confirmatory factor analysis using an R package design for that. It seems, and most of my work has been in the measurement arena, so I thought it would be interesting to do this to illustrate some of the points. So this is the SPSS file that you have sitting out there that you've annotated and probably even done some analyses on in SPSS. You could do some things pretty straightforwardly. One of those is not to do, at least in many aspects, after all, actually, now that I think about it, doing a confirmatory factor analysis. And a CFA would be something that you would be more likely to do in M+ or EQS, or hopefully R. So I hope that made sense, and we'll leave that open, and I'll just pop over to R. So the look of R might be a little differently today. I decided to illustrate how to use R on a Mac. So this is a MacBook Pro that I own, use and love, along with my Dells and other things that my wife says I have too many of. And I try to be ambidextrous when it comes to computers. So I really actually like Macs. They bring a lot to the table that are helpful, including the presentation on the screens are really just exceptional. So the point of this is not to sell Macs. The point is more to kind of illustrate the fact that R and RStudio are multi-platform. So what you see in a Windows environment is what you're going to see more or less in the Mac environment. Mac does some slightly different cosmetic things that are really pretty nice. So anyway, I thought I would just show you how this looks on a cross-platform. I opened up our micro threats Lavaan file and got it set up actually, and I haven't really started a session, so we're down here in the console pane. You can see that this is the startup for R, loaded it up, and then I actually loaded this file, but I haven't done anything yet. The environment pane is empty and the files pane is empty because we really haven't done anything yet to put anything in them. One of the nice things about RStudio is that you can actually resize these windows very nicely, and it sort of depends on where you are in things. If you want to take a look at output, you can actually slide these down. So it's really pretty helpful to do that. And you can slide them this way as well. So that's this is what it looks like in a Mac environment. Pretty nice, and this is the default view of RStudio in Mac. Looks just like it did in Windows. So one of the things that we want to do is to set our working directory. We have to do that before we can really do anything else, especially when it comes to data and maybe saving some output. The Mac path to the working directory is different than the Windows path, the way that it sort of designates path. So how I typically set a working directory, or often do, especially if I'm doing it on a Mac, is to set the directory to the source file location, which you can do through the session set working directory menu item. So that sets our working directory down to this path, this Mac path. So we should be in good shape. We'll see. Sometimes it's a little bit of an adventure. So in this analysis, we want to use some tools, both to do the analysis and then to maybe do some additional interesting things. And I'm dragging this out a little bit. I'm going to hurry it up some, so that I meet my objective of having a short presentation. That might be an impossibility for me. So I've annotated. One of the things you can do in your scripts is to annotate them by using pound signs. So if you put a pound sign before text, basically reads that as a comment, so you can annotate your files. And you might want to do that, actually. It's quite helpful to annotate files. Excuse me for a second. I'm having a little bit of problem with allergies today, and I guess I had to add that informally. So I'll get scratchy here every now and again, and my apologies for that. So in this, you can tell by now that these are really pretty informal for an informal audience at the College of Social Work. So I hope you don't mind the informality of the presentations. That's sort of how I do things. So we're going to use these packages today and make calls to these. The first package that is primary is the Lavaan package, and you can see that it's designed to do SCM and CFA stuff. The diplyr and tidyr and knitr are packages from something called a tidyverse, sort of meta package, and it's a collection of tools that people have developed that are useful seriously useful in data science work. They have features that we're going to use today, and I'll try to remember to show you where the call goes to these functions as we move through. Sometimes it's not entirely clear why you need a why you need a package or a library. So I'll try to make sure I talk about that. So we're going to use the library called parameters, which is a very helpful tool in extracting and presenting model parameters. We want to do a little plot using Lavaan plot, and then this HMIS package, which stands for Herald Miscellaneous, cleverly is something that we're just going to use for importing an SPSS file. It happens to have capacities to read existing package or proprietary package information. So HMIS is useful for that. There are some other tools you can use, but that's helpful. So we're going to use these along the way, and I'm going to kind of show you the programming style that we try to do. I guess it's sort of obvious, but you want to be very structured and intentional and annotated along the way. So this would be a pretty good program. And honestly, if you get good at this, maybe write your own functions, start to be do if-then statements. I'll show you an example of that at the bottom. The structure of your programming syntax is really critical to keep track of. And one of the nice things about RStudio is that it automatically does some things for you that helps to keep track of where you are in your programming process basically that has some rules that it follows. So I'll let you dig into that a little bit more. So the first thing we want to do in our analysis, and this is sort of this we'll start to see as we move along through these presentations. There will be a few more. First thing you have to do is get your data into R so you can actually analyze it. So we're going to use SPSS get. We're going to create a data object through this assignment operator, which is the R assignment operator. So a little left arrow with a little dash. It sort of, I guess, creates an arrow. And SPSS get is a function in HMIS that lets us run out and grab this microthreads ssp.save file. We're not going to use the value labels. These are arguments that you can use. And if you go to the HMIS documentation and if you type HMIS in on a Google search, it'll take you to a PDF that's 455 pages long, and it really illustrates all of the functions and capacities of SPSS get. There's actually a couple pages of them, and these are the arguments that you can use. And then we want to write it to something called a data frame, which is an important structure in R. So we're going to do that, and with a little bit of luck, so I don't have to start the movie over again, or maybe we can figure out if we need to problem solve, we'll click run. Okay. This is a good teaching moment. So I talked about the libraries, but because we didn't, I can't believe that. But what we haven't done is load them into the session. So my bad. That's not a bad teaching moment. So you get an error, then you go like, holy cow, what does that mean? Well, what it means is that we forgot to load our packages. So let's just load these packages into our session. I hope you guys aren't laughing at me out there. You can kind of see what happens down at the bottom here. You're getting some feedback on packages that get loaded. So now we've loaded HMIS. So if we run that, we can see that we get our data file. Great teaching moment. And you can see there are 4,937 observations and 14 variables. So what we know is gender. There's a gender variable at the end of the data file. If we take a look at it, we can see that there's a gender variable. And so what we want to do is to discard that from the data that we want to analyze in our Lavaan program. So we're just going to use this little subsetting routine. We're going to create a new object called scale, and we're going to link it to data, and we're asking R to subset our data set and create a new data set called scale, and we want columns 1 through 13. I hope that made sense. And honestly, there are like 18 million ways to subset data sets. You can put in all kinds of things. I try to keep things simple and do it this way. Just because I'm kind of simple. So, so we're going to do that, and we're going to get our 13 variables. So we're looking good. So now we're going to get into the syntax for Lavaan. This is going to give us some of the answers that we want. So, and this won't be a tutorial in CFA. It's really more a tutorial on how things could work, and packages have features that you have to understand in order to use them effectively. And I hope that made sense, and maybe it will as we go through. So I'm not going to talk a lot about the output of the CFA other than to say that we get it. And so I hope that, I hope all of that made sense. So the first thing we do in Lavaan is to specify a model. And we're going to create an object called scale model. And we're calling it that. That's just the name that we give it. We can call it anything you want. And then we're going to actually change some of that down here. We're going to create another object called FitCat. So our scale model that we're going to use then in our CFA command from our CFA function in Lavaan is to create a scale model, and this is just text that says create a latent variable called scale and have it be a function of these 13 items. And this little operator is the thing that actually makes that work. So, so if you run that, you create an object called scale model. And it gets listed over here. You're going to find this window on the environment window to be quite helpful. It will give you feedback on things that can be diagnostically helpful or kind of confirmingly helpful. So I find myself going to it all the time. So once we tell Lavaan what the model is supposed to be, and those of you who use M+ will know that you do the same thing in M+. You have to designate a model that M+ then understands, and we're doing the same thing in Lavaan. So now we start actually the confirmatory factor analysis, and we're going to create an object called FitCat, my name for it. You can call it anything you want. And it's going to be a function of the CFA command that's going to use the scale model designation that we developed, link it to our scale data, that 13 item data, and we're in this case going to mimic M+, which is an interesting feature of Lavaan. You can mimic M+ or you can mimic EQS. Their computational formulae are a little bit different. So we want to mimic M+ just because Natasha loves M+. And we want to standardize our latent variable here just for identification purposes. And we're going to use an unweighted least squares, means and variances fitting function. There's some discussion in the literature now how the unweighted least squares means and variances seems to be a little bit better and somewhat more accurate than weighted least squares, means and variances. Sorry, Natasha, but there is some literature about that. And then we're going to declare all of our items as ordered here, which is really important. So they're not continuous; they're going to be considered ordinal. So that's, and I'm getting more into the CFA things, but these are all commands in the CFA function. And also we could run this with an SEM designation here too. So once you get that developed and you do a little troubleshooting on it. If things don't work, you can click that, and you really don't get anything. If you create a model, you really don't get any output back other than it was successful. If you don't see an error down here, you're going to assume that it was successful. But you can see over here that we created what Lavaan's calling a large Lavaan object. And we won't click on that. It's kind of lengthy. And if at some point you're interested in any of the objects that get created, you can just take a look at them. So now once we get our model fit, we start to pull it apart. The summary statement here is actually called a method. And it will pull out. And in summary, almost always in anything you do is going to be designated as a method. So if you click on that, I'm just going to go up here a little bit. You'll get some M+ like output that has important information that you can see. You've got a standard and a robust solution, which if you've taken CFA, you know something about. And we have our various parameter estimates that you can see, thresholds, which would be a part of the ordinal data solution. basically. So you get a nice little display here output, and this would be what you would get very likely in M plus or something. Actually, not likely. It would look somewhat like that in M plus. And I can tell you now, I can't help myself when it comes to talking about confirmatory factor analysis. I guess I have tested models in very same models in M plus and Lavaan, and the answers are the same, which is always a good thing. Your answers are not dependent on the program that you use. So in case if any of you are a little skeptical, I can tell you that if you mimic Lavaan, you'll get Lavaan solutions, and they will be a little different than EQS, if that makes sense. So then we have another method here, parameter estimates. These are all considered to be methods, and these will pull out our parameter methods in a slightly different listing. And this it's just kind of lists all the things that we got. These are thresholds and these are factor loadings, and you get some interesting stuff in that you will very likely use in a publication you're doing or examining the output of the model. So we have a method fit measures method or function that give us measures of model fit, and you can see that we have our chi-squared in. These are called scale. We're going to use the scaled versions, which is they're robust, so they're important. And then we have our MSCA values and our CFI and standard root mean residual and correlation root mean residuals output. So with this information down at the bottom, we can assess the adequacy of our model. And it's a plausible model, more or less. Interestingly enough, the output from Lavaan doesn't include often a lower confidence interval. I guess it assumes that it's the upper confidence interval that we're mainly interested in, but it doesn't do that. It might be a limitation. And I never did write to the author about. Had a question about it, but never checked it out. And so then we want to take a look at residuals, the residual function or method, and we're going to use a Bentler residual. I'll let you read up on that. And we're going to create an object called core Bentler, and we could call it anything we want, but we're going to call it that, and we can see that we got that. And then we can pull information out of that with this little link here. Once we have an object, it's got components to it, and we can look at the detail in the output from core once we know what the sections are called by using a $sign. So this actually links us to the summary section of our Bentler analysis, and these are the various measure. Just quickly, we'll take a look at the covariance covariance matrix here. So these are measures that are left over after a model has been fit to the data, essentially, Jesus. And you can see that higher is not good here. So we have a residual problem potentially between item 1 and item 2. That's totally for another day, or for Natasha to talk to you about in her class. But you can get these residuals very nicely using Lavaan. And you can also, these would show up in M+, so you could do that same thing in M+ for sure. A nice thing that this, and I don't know if M+ does this, and I'm not pitting the two against each other. I guess what I want to do is just to say you can trust this program to be, give you the same kind of thing that the M+ program and EQS program gives you. So a nice thing that this is a feature often of output that's in a table in a correlation or covariance matrix is to take the values and create a table of descending values and put the designation in the name column here for in this case in the residual. And I hope I'm making sense here, but what this gives you is the high residuals to the low residuals, so that you can actually not spend time poring over a matrix trying to pull it apart, when in fact what you can get is a nice table display of the item pairs that seem to have the high residuals. I hope I'm making sense there. But it's really actually quite helpful, and I do use that on a regular basis. So we also want to get some tables, eventually in our output, no matter what. In this case, we would like our parameter estimates to be tabled. Basically, our factor loading coefficients is what we're going to do here. And this is a nice little capacity in R to tailor output. It's really quite helpful and is part of the versatility and flexibility of R. So these little gadgets here, symbols here, are pipes. And so how this set of commands here down at the bottom reads is that we want Lavaan to estimate our parameters that are standardized, and we want to pass that information to a filter that actually selects the values that have this operator. And if we go back up here, I probably don't know if I need to do this, but I think it's interesting. So it's operating on this. So it's looking for this operator, which would select then our loadings, which is really pretty cool. And then we're going to pass that to something called mutate, which is a part of the diplyr package, one of the tidyverse packages. And essentially this is a series of if-then, if-else statements. So it's going to create something called stars, and it's going to select on the p-values, and you can see that there's sort of a cascading p-value that you see often. And if you read research articles, you know that p-values often are designated with stars, if that makes sense. And once you get that information then is passed to a select function, where we're actually going to make some changes to some of the values in the output and include the stars in this. And then we're going to pass this. I hope I'm making sense here. And I'm happy to share this. If any of you are interested in these data files, I'd be happy to send them along to you. In fact, I should make arrangements to do that. And then we're going to pass this to something called a cable function, which is a part of tidyr, the tidyverse package. And it's going to, cable means it's going to do a table. It's a cable table. And it's going to be 3, hopefully, digits, and it's going to be formatted in a pandoc format, and it's going to have a caption. So, and the whole point of my sort of going on and on about this is that we can end up with a very nice table. And this is part of the versatility of R in terms of its abilities to provide flexibility relative to output. I mean, it's really just, you don't typically get this kind of flexibility in many of our proprietary packages. So sort of what you get is what you get. And in this case, what you get is what you want to get, if that makes sense. So if we run this, it will run this set of commands in its entirety, and we get a table that looks like this. Now it's text. I mean, it's not an HTML table or a PDF table, but it's a nice enough table, and you can you can see how it sort of lays out, and we have all of our significances on all that. So, it's a nice little display it's really pretty decent. And we can also just do our, this is a parameter. So this is the interesting package that I mentioned up above called parameters, and it's it's operating on the same objects, and it's fairly simple, and it gives you the same answers in a slightly different format. I mean, this is a different package, a different library that gives us the same answers. Thank goodness for that. Let me go down and let's do this. So we get really the same answers. We always keep our fingers crossed on that. And then with the addition of with this package of confidence intervals, which you don't necessarily get from the regular output. I'll have to double check that, but definitely you get CIs, which are really actually quite helpful, as you know. And then finally, we have a plotting function that we can use in our analysis, and this is really bare bones, but this is a plotting function that will show up in the viewer. It's interesting that it doesn't show up in plots, but it shows up here. And this is actually LevonPlot is a package that you have to load over and above Levon, and it's got a set of arguments that you can use. I just used the simple default here, adding coefficients, and you have to give it a name or it won't run, interestingly enough. But you can see what this looks like, and I'm not sure if you can change the orientation. This isn't necessarily the way we typically do a CFA plot, but it's just an illustration of what you can do. And as I recall, there are some extensive commands in the package that you could use. So that's pretty much the end of this presentation. Hopefully I met the objectives of how to get SPSS file into R, and then how to load some packages that you're going to use in the analysis, and how you can read in a data file, the SPSS data file. It's all pretty simple. And then the concept of objects, data and scale model. These are all objects. Anytime you see something to the left of this assignment operator, it almost always is an object. And I'll let you learn about objects if you get interested in R. They're really very helpful to understand. Objects and attributes really give R enormous flexibility, and once you catch on to them, you can do some very interesting things. So that's it for today. Hopefully helpful, and I hope you don't mind my informal style. I don't know that I can change it at my old age, but hopefully it's not distracting and you got something from this presentation. Our next presentation is going to be designed to take a look at R Markdown as a way to develop some interesting reports, and I think you'll enjoy that. So I'll get that posted here over the next couple of days, and you can have a look at that. I actually don't know when you're going to look at this, but I'm trying to get these done in fairly short order. So anyway, that's it for today.